Okay, so again, folks, what we want to remember is, first of all, different samples will result in different sample statistic, and the probability distribution of the sample statistic is the sampling distribution, and the sample statistic may be very likely to be different than the population parameter. All right, so I believe we were, this is where we had stopped in our last class. So let's start with our definitions of sampling error and non-sampling error. Simply stated, folks, it's the difference between the population result versus a sample result. In this particular example, we are talking about a sampling error when we are dealing with sample average X bar and the population average mu. Okay, so the difference between X bar and mu is what we call the sampling error. More generically speaking, it's the difference between a sample statistic. A sample statistic could be the mean, could be the standard deviation, could be the range, could be the median, could be the mode, could be the standard deviation, could be the proportion. Doesn't matter. Statistic means a lot of different things. And population parameter, again, could mean a lot of different things. We can calculate about the population mean, the population range, the population median, the population standard deviation, the population proportion. But the difference between the sample and the population is the sampling error. And in this chapter, let me go ahead and give you that heads up. We will deal with two type of sample statistic. The first one is the sample average, and the second one is the sample proportion. So we'll be comparing these two statistics with the population mean and the population proportion. And in our first definition, since you're, at this stage we are working with sample means and population mean, our sampling error is the sample average X bar minus the population mean mu. Okay, and this assumption is important. The sample is random. Okay, when it's random, we know we leave our selection of sample members completely up to chance, and there is no issue like bias or preferential treatment, whatever. Bias is preferential treatment. And no non-sampling error is made. We will get into this issue of non-sampling in a minute. Right here, folks. Go ahead and read the definition, if you will. Basically, folks, human error, we make a mistake that that results in an error. All right, if you would please go ahead, folks, take a reason for these non-sampling errors. All right, folks, let me try and give you a few examples, especially on number 1, 2, and 3. And we actually have a example in the next few pages, bullet point number 4. So bullet number one, suppose I'm interested in measuring the IQ of university students in Bangladesh. And you know as well as I do, probably better than I do, that there is a lot of universities in Bangladesh, and some of them are quite good. Hopefully, that indefinitely on top of a restaurant, and the appearance is so weird. Anyway, I'm sure there are lots of these universities. Suppose I'm interested in the IQ of the average university student in Bangladesh, and my choice of sample is strictly limited to North-South University students. And I have shared with you in the past that I think that we are lucky that we get some of the best students in Bangladesh. Skewed because my sample is not random. For the sake of convenience, my sample is biased because I'm only selecting North-South University students, and my personal opinion is that our students are smarter than other university students. Okay, number two, the questioning matters. You probably understand this well because you take exams and you probably have, maybe even in this class, um, that you don't understand the question and you need some explanation. So, and this happens quite a bit for researchers. And, oh, I was correct. The population average is 80.60, whereas this population average mu is 80.6. But suppose we do this sample only. We do this sample where the three students in the sample, their scores are 70 and 80 and 95. And so this sample average is 81.67. Okay, so, oh, I was correct. The population average is 80.60, whereas this particular sample, the sample average is 81.67. So the sampling error, as we saw earlier, is x bar by this mu. Sampling error is 1.07. Any question about this example so far? Just calculating the population average and the sample average in this specific case. All right, and suppose now to establish the non-sampling error, suppose I make a mistake, and I make mistakes all the time. You guys saw that. Suppose we make a mistake and we, instead of typing in an 80, we type in an 82 when we are calculating the sample mean. So with that typo, and it's a typo, happens all the time. With that typo, the sample average is 82.33. Okay, so now the error with the typo, the sampling error with the typo is 82.33 minus 80.60, 1.73. But once we start looking at it, doing some quality inspection perhaps, making sure we haven't made a mistake, we start looking at it and we see that we made a typo. And we know we already did it. The sampling error was 1.07. But now, with the typo, the error is 1.73. That means there is something in this 1.73 that is the result of the typo. That is what we would call the non-sampling error. So since the error with the typo is 1.73, the sampling error that we saw calculated earlier is 1.07. So the difference is 0.66, and this is what we would call the error that's due to my typo. This is my non-sampling error. Fauzia Afri.